Hi and Assalamualaikum. Today we would like to present our MAT523 Linear Algebra 2 group project for least square solution and best fit curve, a study on the relationship between number of projects completed and satisfaction rate. Our group members is Nur Fitri Zulaika binti Zainuddin and Nur Alia Maisara binti Safi'in. The list of contents is we have introduction, data, implementation, graph, analysis, and conclusion. Introduction. This study investigates the relationship between the number of projects complete and satisfaction rate, aiming to understand how these factors interact to balance productivity and happiness. To analyze this, the least square method was used to create two regression models, a linear model and a quadratic model. So the data set include 20 observations covering project completion 1 to 35 and satisfaction rates, sourced from a productivity and satisfaction tracking system. The goal of this research is to clarify the relationship between the number of projects complete and satisfaction rate.
The data for the study was obtained from Kaggle. The top 20 observations were taken and this dataset was visualized with the number of projects completed out of 25 as independent variable x and satisfaction rates as dependent variable y. The next part is implementation of the study. The relationship between x and y was examined through two models, a linear model and a quadratic model. First model is linear model. Mathematically, it's represented as y equals to a plus bx. M is the design metric. It contains the independent variables. For a simple linear regression, this metric consists of two columns. The first column is all ones that represents a. The second column is the number of projects completed out of 25, which is x. Then, the data generates a system of linear equations mv equals to y. Its normal equation is when m transpose m multiplied by v that is equal to m transpose y. Next, to find the best fit linear curve, we need to find the least square solution v by solving the inverse of m transpose m multiplied by m transpose y. Thus, the best fit linear curve is y equals to 277,603 over 6638 minus 1,232 over 3319x. The error vector is E equals to y minus m multiplied by the least square solution, and the magnitude of the error vector is 55.9221. Next model is quadratic model. The equation for the quadratic model is y equals to a plus bx plus cx squared. And matrix contains three columns. The first column is all ones that represents a. The second column is the number of projects completed out of 35, which is x, and the third column contains x squared. Next, the data generates a system of quadratic equations mv equals to y. Its normal equation is when m transpose m multiplied by v that is equal to m transpose y. Next, to find the best fit quadratic curve, we need to find the least square solution v by solving the inverse of m transpose m multiplied by m transpose y. The first row represents a, and the second row represents b, and the third row represents c. Thus, the best fit quadratic curve is y equals to 196447833 over 4544083 minus 3611984 over 4544083x plus 382535 over 1817633x squared. Lastly, the error vector is E equals to y minus m multiplied by the least square solution, and the magnitude of the error vector is 55.2740.
So next graph 3.1.1 is linear model. The data point show that it has a negative correlationship because the data points are spread out and show that there is negative correlationship between number of project complete and satisfaction rate. So next graph quadratic model, it shows that it has a negative slope, meaning that satisfaction rate decrease as the number of project complete increase. The line slope indicates that the steepness of this descent. So the conclusion is, since the linear model oversimplifies the connection, it is not the best option. It will fit the data better with quadratic model. Next, graph 3.2.1, the scatter plot shows a curve pattern for linear model, indicating there is a nonlinear relationship between satisfaction and the number of projects completed. Initially, satisfaction increases with more projects, but after a certain point, it starts to decrease, suggesting that there is an optimal number of projects before satisfaction grows. For graph 3.2.2, quadratic model show regression curve fits the data well. It shows the relationship between the number of projects complete and satisfaction rate by showing that satisfaction increased initially before declining after reaching its peak. So the conclusion is the quadratic model is better since it highlights the trend and relationship directly. So moving to the analysis, the quadratic curve show that while satisfaction rate increased with more projects, it eventually decreased after reaching a certain point. In conclusion, the quadratic model is the better option for understanding how project completion affects satisfaction. Conclusion. In conclusion, this research has given us a greater understanding of how to use mathematical techniques to examine the resolve issues with actual data. Because of its smaller error magnitude, the quadratic model provides more accuracy when compared to the linear model. Nonetheless, the slight variation in errors between the two models suggests that additional variables might also affect the outcome.